So the next thing I want to talk about is translational equilibrium. The idea of translational equilibrium is pretty important to the world of physics. When we talk about equilibrium, we're talking about everything being in balance. And translational is just meaning that it's in the x, it's in the y direction, even in the z direction. That there's a balance in those directions. Well, they're balanced in the x, or balanced in the y, or the balance of the z. Remember they're independent because of orthogonality. So you can have a translational equilibrium in one direction, not necessarily have it in all. But anyway, translational equilibrium means that the sum of all the forces on that object are equal to zero. So that means that when we consider all the forces acting on that single object, that single mass, when I add them together, it'll equal to zero. Now, does that mean that the object is moving? No, it doesn't actually. It doesn't mean that the object is stationary or moving. It does mean one thing. If an object's in translational equilibrium, that means that the acceleration is equal to zero. That there is no change in the object's motion. Okay? So that's what translational equilibrium means. It doesn't mean that the object's not moving. I mean, remember, acceleration is nothing but changes in motion, the rate in which motion changes. Change in motion per time, or change in velocity per time. That's the precise definition of it. But when we talk about acceleration equals zero, it doesn't necessarily mean that the velocity is equal to zero. An object can continue to move at a constant velocity. Okay? Being in translational equilibrium because it is moving at a constant velocity and have an acceleration equal to zero. Perfect example of that is your car. If you're on the freeway and you're driving on a long straight road at 55 miles per hour the entire time, then you're in translational equilibrium. Are you stationary? Heck no. That just means your acceleration is equal to zero. But talking about that vehicle, the equilibrium you have, you got drag in your face, and you're producing this force applied by the engine in the opposite direction. You've got gravity pulling the car down, and then you've got normal pushing the car up. So that would be like the applied force of the engine on the car, the drag, the air drag on the road, and some friction, but that's not there. Well, I mean, drag is basically friction. My normal and my weight, they're all in balance, but it doesn't mean that the car is stationary. It can still be moving. So they're all in balance with each other. Acceleration is equal to zero, but that doesn't mean that the velocity is equal to zero. Just means that the velocity is constant. Okay?